Welcome to the deep dive. Today, we have pulled together an absolutely fascinating and, I gotta say, a pretty dizzying stack of source material.
It really is. We're starting with cutting-edge AI architecture, specifically these tiny AI models.
And then we're jumping all the way up to abstract philosophy on hierarchy, and then finishing with a really dense structural analysis of modern class.
It sounds like the dots are miles apart, I know. But our mission today is actually pretty specific. We're looking for the hidden structural laws, the rules that link all these different systems.
Right. We want to understand how any system, whether it's cognitive, social, historical, how it organizes itself, how it grows, and how it determines power based on its internal relationships.
And the big idea here, the thing that kind of ties it all together, is this notion that bigger isn't always better.
Yeah, that scale isn't everything. We're going to dig into how connectivity and your position in the architecture are often the real drivers of intelligence and change, not just raw size.
And that challenge to size, it starts right away in the world of AI. I mean, for the last decade, the mantra has just been bigger is better.
Oh, absolutely. It's been a race to build models with more and more parameters, feeding them more and more data.
But this one research paper we have offers a really powerful counter-narrative. It shows how ingenuity can just flat out beat massive compute. They call it the tiny recursive model, or TRM.
And when you say tiny, you mean tiny.
I do. These TRM models are incredibly small. We're talking 5 to 7 million parameters.
Which, just for context, is nothing. The big LLMs we talk about all the time have parameters in the billions, sometimes even trillions.
Exactly. They're orders of magnitude smaller. And what they accomplish with that is, wow, it's just astonishing.
It really is. They put these tiny models up against the huge state-of-the-art ones on tasks designed to test complex reasoning. So let's talk about Sudoku Extreme. It's a really difficult logic test. The DeepSeek R1 model, which has 671 billion parameters, it achieved 0.0% accuracy.
Zero.
Yeah.
0%. It couldn't grasp the structural logic. Despite its enormous size, all its training data, it just failed completely.
And yet, the TRM-MLP, with just 5 million parameters, got 87.4% accuracy.
I mean, that result is a seismic event in the AI community. It tells you point-blank parameter count is not the same thing as reasoning capacity.
And it wasn't a fluke either. They tested it on the abstract reasoning corpus, IRC-AGI2, which is often seen as a benchmark for general intelligence.
Right.
The 7 million parameter TRM was competitive with models like Grok 4 Thinking, which has something like 1.7 trillion parameters.
So it strongly suggests that for problems that need that deep, focused structural logic, it's all about the design. It's the architecture that matters, not just scaling up.
So what's so fascinating is how they got there. The breakthrough didn't come from adding more stuff, more layers or parameters.
No, it came from radical simplification. The researchers actually stripped complexity away from their previous model.
And they did some things that they seem completely counterintuitive if you've been following the AI hype cycle.
They do.
Yeah.
Like they took two separate processing networks and replaced them with a single one. That cut the parameter count in half, and it boosted performance.
And they also found that, going against that deeper is better idea, a simple 2-layer network was actually better at generalizing than a 4-layer one for some tasks.
Right. And the reason for that is probably the most important insight from this whole stack of research. When you have problems with very little training data like Sudoku Extreme, which only uses about 1,000 examples.
Right. That's not a lot.
No.
Yeah.
A massive network gets penalized for that. It doesn't learn the logic, it just memorizes the training examples. It's called overfitting.
But a tiny network can't do that.
It can't. It's forced by its own constraints to find the underlying generalizable rules. It has to look for the structure.
So the constraints actually breed intelligence here. Okay, so if they simplified the model so much, how did they give it that superior reasoning power? What's the secret mechanism if it's not size?
The mechanism is recursive reasoning.
Okay.
So think about how standard LLMs work. They're autoregressive. They generate tokens one after another in a sequence.
Right, one word at a time.
And the source material points out that this carries a high risk of error since a single incorrect token can render an answer invalid. The model gets locked into a bad path.
It's like writing a sentence, and if you make one typo in the second word, the rest of the sentence is just doomed to be nonsense, and you can't go back and fix it.
That's a perfect analogy. PRM breaks that cycle.
Yeah.
It refines its own work over and over. It allows the model to rethink its answer, repeating the evaluation up to 16 times before giving a final solution.
And this is where the architectural genius comes in, the part that makes it so efficient. The model keeps a clear separation between the proposed answer itself, which they call Y.
And the latent reasoning feature, which they call Z. So the thinking part.
Right.
To give you an analogy, it's like you're writing a complex paper. That's your Y. But you also have a separate stack of scratch paper with all your notes and outlines. That's your Z. In the TRM, the act of thinking, messing around with your notes on the scratch paper, it doesn't immediately change the final draft. That separation lets the model do a global refinement. It can critique the whole answer, not just spit out the next word.
Which is way more efficient than a trillion parameter model that has to recalculate everything from scratch with every little change.
Exactly.
That concept of tailored architecture is so interesting, especially with what they did next. They had a real attention isn't all you need moment.
They really did. For the Sudoku task, which is super structured, right?
Right.
It's always a fixed 9x9 grid.
Always.
So they replaced the standard self-attention layer, the thing that all modern LLMs are built on, with a much simpler multi-layer perceptron, or MLP.
And the accuracy jumped from, what, 74.7% to 87.4%.
It's the ultimate proof that you have to customize the architecture for the problem. Self-attention is a universal hammer. It's great for handling messy, variable text from the internet, but for a fixed, structured puzzle, it was actually a liability. Simplicity won.
Okay, so we've established that for a cognitive system, success isn't about brute size. It's about efficient, recursive structure and these tightly integrated relationships. Now let's pivot. Let's take that insight and apply it universally, moving from a tiny AI to any layered system.
This is the leap. This is where the sources formalize what they call the first law of artificial general intelligence. We're moving from today's AI to, future system design.
Okay, let's unpack the structural law. What's the fundamental idea about how these systems grow?
So the law states that in any layered architecture, it's the intermediate coordination layers that will have accelerated growth rates.
The middle layers.
The middle layers.
Okay.
They'll grow faster than the foundational processors at the bottom and faster than the high-level strategic controllers at the top.
Okay, so the middle is the engine of intelligence, but why? Why is that the evolutionary sweet spot?
Because that's where the maximum flow and constraint happens. The middle layers are forced to integrate information from two opposing directions.
So they get the raw data from the bottom.
Right? The specialized material, the basic skills, and they get the high-level, abstract, strategic goals from the top. Their entire job is translation and synthesis.
This applies so perfectly to human organizations. The sources use this great analogy from educational management. You've got teachers at the bottom dealing directly with the students, and at the top you have the district admin setting these abstract goals like increase efficiency by Q3.
And the ones under the most intense pressure, the ones forced to grow their capacity the fastest, are the instructional coaches, the mid-level integrators.
The middle layer.
They have to translate teacher insights from below into reports that satisfy admin goals from above, and then translate those admin goals back down into stuff teachers can actually use. They're the synthesis mechanism. They are perpetually optimizing, and so they accelerate their own complexity.
This totally changes how you view a hierarchy. It's not a ladder. It's not a pyramid. The sources say intelligence is topological. It's a web.
A tangled hierarchy. That's the term they use, and it's a critical concept. A tangled hierarchy is one where all the levels are interconnected, creating what they call strange loops.
Which is like circular causality, right? Self-reference.
Exactly, where a high-level instruction might reference its own process. These loops are what enable metacognition, the system's ability to look at and critique its own thinking.
Just like the tiny AI's recursive reasoning.
Precisely. And the middle layer is where that self-reference is most intense and most valuable.
And if that law holds for internal cognitive structures, we can extend it outward to social structures. This leads to the social integration principle.
Which, simply put, is that intelligence is proportional to integration capacity.
So being connected makes you smarter.
Basically, yeah. The sources explicitly contrast a connected system with what they call the conceited loner, whether that's an isolated AI or a person or even a society that just resists outside input.
And why does that isolation slow down growth?
Because it imposes hard limits. You have limited input, a narrower perspective, and you have fewer contradictions to force you to get smarter. A socially integrated mind or system benefits from collaboration, diverse perspectives, and that constant pressure to synthesize new information. It leads to much faster development.
This insight that connectivity and integration drive growth, it scales up perfectly to the largest systems of all, human history and geopolitics.
Right. So now we shift the topology from cognitive layers to geopolitical nodes. We're talking civilizations, states, empires. History, from this viewpoint, is a continuous topological process.
And the sources use this really powerful quantum metaphor to describe it. They compare historical stability or structural maintenance to quantum superposition.
Superposition, in this analogy, is a coherent state that holds together despite all the stress. Think about the Roman Empire, held together by the Pax Romana and its road network.
That's its connectivity.
That's its connectivity. Or the 1,300-year stability of the Chinese imperial examination system. That was an integration layer connecting the state to its scholars. That's structural maintenance.
And the flip side is structural upheaval collapse, revolution, which is like quantum decay.
Decay is that irreversible collapse into a new configuration. It results in topological rewiring. The connections and power patterns of the world are just fundamentally changed.
Like the collapse of the Soviet Union.
Perfect example. That wasn't just a political event. It was a topological decay that rewired the entire geopolitical map. It enabled new nodes, new connections, all across Eastern Europe. History is just this constant oscillation between those two states.
And that cycle of maintenance and decay leads us straight to our final source. How are these relationships in power defined in our current economic structure? We're moving into Marxist class analysis.
And this framework is purely structural. It's shifting focus again, this time to economic relationships that are defined by ownership and exploitation. The key here is the impartial definition the source uses. Class is determined by your relationship to the means of production.
Not your income, not your education, not your lifestyle.
Correct. And this is where the definition really clashes with the mainstream idea of the middle class, especially in the U.S. This analysis sees two major structural classes.
Okay, what are they?
First, the capitals class. These are the people who own the means of production, the buildings, machinery, resources. They hold economic control and dictate the terms.
And the other class?
The working class or the proletariat, this is the vast majority. They have to sell their ability to work for a wage, simply because they don't own the means to generate wealth on their own.
And it's so important to clarify who is in that working class. It's not just blue-collar factory workers.
No, absolutely not. The sources are clear. This includes anyone selling their labor power, whether you produce physical goods or services. So teachers, nurses, and increasingly professionals.
Right. They talk about this proletarianizing trend.
They do.
So how can a highly educated, well-paid computer programmer be defined as working class?
Because their relationship to the means of production is still one of dependence. The programmer might get a high salary, but they don't own the company's servers or the proprietary code or the building.
They're still selling their specialized labor time.
Exactly. They lack control over the strategic decisions, the product, the conditions of their work. The highly paid coder writing dictated code is just as structurally dependent as the factory worker. It's a shift from being an autonomous professional to a salaried routine worker.
So wealth and poverty are just symptoms, not the determinants of class. The real determinant is that structural relationship of control and ownership.
Yes. And finally, the source emphasizes that this capitalist structure, by its very design, requires what it calls a reserve army of laborers. In other words, unemployment.
Yeah. And this isn't an accident of the system.
Not at all. It's a critical functional element. The reserve army is a mechanism used to discipline the paid workforce. If there's always a big pool of unemployed workers ready to take your job,
What the sources call disciplining the workforce.
then the people who do have jobs can't aggressively demand higher wages or better conditions. The fear of being replaced keeps everything in check, and it maximizes profit extraction.
That's a very clear, impartial, structural explanation of the mechanism. Okay, and finally, there's a distinction between a passive and an active class.
Yes, the difference between a class in itself, which is just the objective reality of sharing the same relationship to production, and a class for itself.
Which is when they get organized.
Right, when they're in active, organized pursuit of their common interests. And moving from that objective reality to conscious, collective action is what requires solidarity.
This has been a truly monumental synthesis. We've gone from the tiniest AI architecture to the largest societal structures.
And the core insight woven through all of it is, I think, undeniable. The success or failure, the power, the learning rate of any system, a tiny AI, a human organization, a civilization, it's all determined by its integration capacity and its architectural position.
The tiny recursive model wins by tightly integrating its reasoning loops. General intelligence accelerates in those intermediate layers of synthesis, the organizational middle.
Social systems get smarter by integrating diverse connections, avoiding the stagnation of the conceited loner.
And societal power is defined by that structural relationship to production and control.
Every single system, from micro to macro, is a tangled hierarchy, and the components that are positioned to synthesize, translate, or control that critical flow of information, those are the ones that drive change and growth.
So we'll leave you with this final provocative thought to chew on. If intelligence and growth flow most intensely through the middle layers of any tangled hierarchy, what current global institutions or technologies are functioning as that accelerating middle layer right now?
You can think about large-scale data platforms or
Yeah.
maybe global regulatory bodies.
So what are the implications for global power dynamics of controlling that critical integration point? Go forth and explore the structure of the world.